Hey guys, it's Mr. Morse doing an equilibrium, and it's actually an acid base and solubility demonstration here all at once. It's called MoM to the rescue because it's using MoM, which is milk of magnesia. It's actually something you could find at a pharmacy or drugstore or a grocery store. It's a saturated solution or a cloudy solution of magnesium hydroxide. In there is also an acid base indicator, universal indicator, and we've got a color chart that goes along with that. When it's red or orange, that tells me I have an acid in there. When it's blue and purple, that tells me I have a base. And right now it is purple because we only have magnesium hydroxide in there. So what we have in this equilibrium or in this beaker is the equilibrium between magnesium hydroxide as a solid and its two aqueous ions. So it breaks into magnesium plus or 2 plus and 2 hydroxide minus. And that's an equilibrium back and forth. The ions are separating, the ions are coming back together, and we just have this constant back and forth representative of an equilibrium. But that also means that the amount of solid and the concentration of ions stays constant. With Le Chatelier's principle, what we want to do is add or remove something or do another stress, which could be changing our pressure or volume for gases or changing our temperature for reactions to get it to shift. But here we're going to focus on shifts related to concentrations. So what I have here is hydrochloric acid. So when I put just a little dribble of hydrochloric acid in there, we see a really quick flash of color. It starts off kind of orange, goes yellow to green, but then ultimately we come back to this blue or purple. So if we think about this in terms of the reaction, the acid is neutralizing our base or our hydroxide. So this is the equivalent of taking away one of our products. When we take away one of our products, the equilibrium has to shift to make that again. So initially with the stress, the addition of the acid, we saw a big drop in pH, a color change. But then it came back to where it was. We got back to the same color or very, very similar because the reaction shifted to make more of the ions again. And we can repeat it with a little bit more acid. We saw the color flash at the bottom. A little bit longer there. And even longer here. Each time we remove some product, but we're still in an equilibrium system, the forward and reverse continue, and those forward and reverse continue until we get back to that same ratio we had previously. This one's a little bit harder to get just right, when I'm just pouring random amounts. I want it to kind of, let's see if I can get it to end in that yellowish. Oh, I already overshot it here. So I kind of passed my initial goal, but we're going down to the final thing. If I added tons and tons and tons of acid, that would be like removing my base, removing my base, removing my base. And as a result, in the attempt to get back to equilibrium, the reaction will shift and shift and shift. And I'm not sure if I can go back the other way if I have enough hydroxide there at all. So what I'm going to grab instead, so it'll be a little bit different from what we'll see on our paper, is some sodium hydroxide. When I put hydroxide in, we see that it goes purple, but there's enough acid to neutralize that. But I can add some more of one of my things, causing it to go back towards that direction. The other thing that I have here is magnesium nitrate. Extra magnesium can also shift the reaction. And it's hard to see in this video, but we're starting to see a little bit more solid float around. And you may or may not have noticed it initially, but it was very cloudy when it was purple or lavender. And even when it was blue and green the first time, it was cloudy. That's because there was a lot of solids still floating around. Each time that we shifted to the right, not only did we make more hydroxide and ionize more of the magnesium ion, but we also dissociated and therefore dissolved more of the magnesium hydroxide. So as we look at all of these different shifts, what we're looking for is any color change that indicates that we are changing one of our components. any maybe texture or visual change that shows me something has changed and how the reaction shifted to get back to the ratio it was in earlier.